Okay, so today we're going to dive into something pretty cool.
Yeah.
I think
Yeah.
we're looking at the Polytech STEM Science Lab,
Right.
and this is a system that's designed to really like revolutionize how physical science is taught,
Hmm.
um, from like upper elementary all the way up through high school.
Yep.
So this is going to be fun, I think, to sort of unpack how all this works.
Absolutely. And it's interesting, we often see like isolated gadgets and things like that, but this is really designed as like a complete solution.
Oh, wow.
It's not just like here's a sensor and figure out what to do with it.
Right.
It's like a fully integrated system.
Well, that's what's always so hard for teachers, right? Is like,
Yeah.
I have this great gadget.
Yeah.
How do I integrate it into my lesson plan?
Exactly. So this is really exciting.
Yeah, and for you, the listener, imagine having access to really precise measurements.
Right.
Like you can get very detailed digital data.
From your experiments,
Mm.
you have theoretical resources that are available to you in real time as you're doing the experiment.
That's amazing.
So you can kind of like check your thinking as you go.
That's so cool.
And then you also have all these electronic components like sensors and LEDs and things like that
Yeah.
you can actually integrate into the experiment.
So it's not just like a pre-packaged experiment kit. It's like
Right.
you can really go kind of crazy with it.
Exactly. And it uses open source software, which is really cool because
Wow.
it means there's a high degree of flexibility.
Oh, awesome.
So you're not locked into this rigid system.
Uh-huh.
You can adapt it. You can even expand on it.
Wow.
And I think that's really powerful for educators because you can really tailor things to your specific learning goals.
Yeah, and for students to be able to kind of like go off on their own and say, "Hey, I
Mhm.
have this idea.
Exactly.
Let me test it."
Yeah, and we've seen, anecdotally that this actually leads to more engaging experiences for students.
Right.
Because they're not spending all their time struggling with like setting things up.
Right.
It's very easy to use.
Right.
So they can actually focus on the science.
Yeah, and it sounds like, you were talking about the data they can get.
Right.
There's also this classroom response system, which
Mhm.
is optional,
Hmm?
but can really help teachers keep track of like student progress in real time.
Absolutely.
Yeah.
Yeah, you can do like real-time quizzes and things like that and get performance data so you can really see how students are grasping the material.
So for someone who wants to kind of envision this in their classroom, how is this all laid out?
So the whole lab really centers around three main components.
Okay.
First, you have the teacher's set, which is called the BT11,
Okay.
and this is basically a self-contained kit.
Oh, nice.
It has all the lab equipment that the teacher needs,
Cool.
and it's got sensors that plug directly into a PC.
Wow, so it's really just a plug and play.
Exactly.
That's great.
And then it uses software called iLab for analysis, so the teacher can really like get into the data and look at it in detail.
So that's like the teacher's kind of powerhouse.
Exactly. Yeah, it's very portable. It's
Right.
all in one case.
I like that.
And then for the students, there's the student set,
Okay.
which is called the SmartBlocks S5.
Smart Blocks S5, got it.
Yep. And this one's built around an Arduino microprocessor,
Okay.
which, your listeners are probably familiar with.
Yeah, very popular for this kind of thing.
Exactly.
Yeah.
Yeah. And it includes a bunch of different electronic components that the students can use.
So they're not just kind of watching the teacher do it, they're actually
Right.
doing it themselves.
Exactly. And what's really neat here is that they have a couple of different options.
Okay.
They can either run these pre-designed experiments
Okay.
through an app called STEM Lab,
Okay.
which gives them a more guided approach.
Got it. So it's like a little bit more structured.
Exactly.
For
Yeah.
students who need that.
Yeah. Or if they're feeling really adventurous, they can actually code their own experiments
Wow, that's great.
using a block programming language called ARD.icon.
Okay, so there's that flexibility that we were talking about before.
Exactly.
Yeah, that's great.
And then, of course, you have the optional Academia CRS,
Oh,
which
great.
adds that layer of like immediate feedback and assessment.
Yeah.
So it's really a very comprehensive system.
And all this runs on like a standard PC.
So for the teacher and student sets, you just need a PC or an Android tablet.
Okay.
And then the CRS optionally uses Android mobile devices as like virtual clickers.
Okay, so it's really accessible to a lot of schools already.
Exactly.
Yeah.
You don't need any specialized equipment.
Right.
You probably already have everything you need.
And then I know we were talking about, these are portable units.
Yeah.
Can you talk a little bit more about that?
Yeah, so both the teacher set and the student set come in these briefcase-sized kits.
Wow, that's cool.
So you don't need a dedicated lab space.
Right.
You don't need any permanent installations or anything like that.
So you could take this from classroom to classroom.
Exactly. Yeah, you just, pop open the briefcase and you're good to go.
That's amazing. And you don't even need an internet connection.
For the core functions, no.
Wow.
You don't need the internet. The optional TRS does use Wi-Fi,
Okay.
but everything else can be done offline.
So it's really flexible in terms of where and how you can use it.
Absolutely.
Now, I know the material mentions a possible, like, 2-hour class structure. Can you
Yeah.
walk us through that a little bit?
Yeah, so they suggest starting with like a teacher-led session
Okay.
where the teacher is covering the theory
Okay.
and maybe demonstrating an experiment using the teacher's set.
Got it.
And then the second hour would be dedicated to the students
Okay.
working in groups
Okay.
with their student sets
Okay.
to kind of model and present their own STEM activities.
So it's a nice kind of mix of instruction and then exploration.
Exactly. Yeah, and I think that's really powerful because it allows students to kind of like build on that foundation of understanding
Right.
and then really apply what they've learned.
Yeah, and when they get to present it to their classmates, I mean,
Right.
that's where the real learning happens.
Exactly.
So can you give us some concrete examples of the types of experiments that teachers and students can do with this lab?
Yeah, absolutely.
Mm-hmm.
So the teacher experiments cover a lot of fundamental areas like volume and density,
Okay.
buoyant force,
Yeah.
different types of oscillations,
Oscillations, so
like pendulums and springs and things like that.
got it.
Phase changes of water.
Like freezing and melting?
Exactly.
Okay.
Even soil pH testing.
Wow, so really wide range of topics.
Yeah, it really gives you a good foundation in those core physical science concepts.
And then what about the students?
So for the students using the STEM Lab app, they can investigate things like the Doppler effect
Okay.
using a radar simulation.
Oh, cool.
They can study pendulum motion and energy and explore the volume density and buoyancy of objects.
So really getting into the physics there.
Exactly.
Yeah.
And then for those using the ARD.icon block programming, they can tackle experiments like variations on volume and density,
Okay.
buoyancy circuit behavior, the greenhouse effect, and water retention in soil.
So even getting into some environmental science there.
Exactly. Yeah. So it really spans a wide range of disciplines.
So it sounds like this system is really trying to change the way that we teach and learn physical science.
Absolutely.
Yeah.
It's really exciting to see this kind of integrated approach,
Yeah.
where you're blending traditional experiments with these modern digital tools and computational thinking.
Right. And I think it raises a lot of interesting questions for us.
Hmm.
Like, how is this going to reshape physical science education in the years to come?
Yeah.
What new questions are students going to be able to ask and explore
Right.
when they have these capabilities at their fingertips?
It's really game changer.
It really is.
Yeah.
Well, this has been fantastic. I'm so glad we got to dive into this today.
Me too.
I think it's really exciting to see what's happening in the world of science education.
Absolutely.
And for you, the listener, we'd love to hear your thoughts on this.
Yeah.
Have you seen anything like this in your own classrooms or schools?
Mm-hmm.
What kind of impact do you think this could have on student learning?
What new possibilities might it open up?
Yeah, leave us a comment below and let's keep this conversation going.
Sounds good.
Thanks for joining us.
Thanks for having me.